Hello, I'm Joanna Lewis, and I work at the National Institute for Health Research Health Protection Research Unit in Modelling Methodology at Imperial College London in partnership with Public Health England. I'm going to introduce some work that I did with Peter White, estimating local chlamydia prevalence using publicly available surveillance data. Chlamydia is a common sexually transmitted infection, but it's difficult to control because most cases are asymptomatic and so people don't seek treatment. The high proportion of asymptomatic cases also makes it difficult to know the extent of the problem, so how many people are infected. In England, the National Chlamydia Screening Programme collects good, complete data on the numbers of chlamydia tests and diagnoses, and these data are made publicly available at the level of local administrative areas called local authorities. But the numbers of local tests and diagnoses don't directly tell us about the prevalence. For example, if you test more people, you will find more cases. So if more tests and more diagnoses were recorded in Area A than Area B, was that because there was more infection in Area A, or was it just that there were more tests? And if a higher proportion of tests are positive in Area C than Area D, does that mean that prevalence was higher, or just that there was more testing of people in high-risk groups? The goal of our work was to develop a model which could take data on local testing and diagnoses and use it to calculate local prevalence and incidence. We addressed this question using a simple model of chlamydia infection, testing and diagnosis, to account for the fact that symptomatic people seek testing and treatment, but asymptomatic cases are only detected if the individuals are screened. That means that asymptomatic infections last on average longer than symptomatic ones, and this average duration depends on the amount of local screening going on. We used data from various sources to provide input to our model. The National Chlamydia Screening Programme data on chlamydia testing and diagnoses provided testing and diagnosis rates. Studies published in the literature provided data that gave us rates of treatment seeking by symptomatic individuals and also natural clearance of untreated asymptomatic infections. Finally, we obtained estimates of the proportion of untreated infections which are symptomatic by calibrating to national chlamydia prevalence in the NatSal-3 population-based study. These data were supplied as inputs to the model, and the model then provided outputs in the form of the screening rate of asymptomatic cases, the chlamydia incidence, and chlamydia prevalence. Using our method, we were able to estimate local chlamydia prevalence in every local authority in England, and that data is shown on the maps. Although there was uncertainty in the absolute values of the prevalence estimates, there was also strong evidence of variation in prevalence between local authorities across the country. We also found that prevalence was generally higher in women than in men. Finally, we looked at the relationship between incidence and prevalence in opposite sexes, and we found that local incidence in each sex was broadly proportional to local prevalence in the other. The effect of prevalence in men on incidence in women was stronger than the effect of prevalence in women on incidence in men, which suggested to us that the rate of male-to-female transmission is higher than female-to-male transmission. The main limitation of our study was in the natural history parameters that were used as inputs to the model, and in particular the proportion of incident infections which lead to symptoms. In this study, we calibrated that parameter to a national prevalence estimate, but in future, data could be collected on the reason that people come for chlamydia testing. Was it because of symptoms or for a routine screen? And that would inform on this missing parameter. The work is important because it provides a method for estimating chlamydia incidence and prevalence at a local level using data that is already being collected. And this information could be used to understand where prevalence is highest and to direct resources to where they're needed most.